Hi, welcome back to Leetcode. So, in this video, I'm going to discuss the third problem from today's weekly contest. The problem name is smallest all ones multiple. So, you are given a positive integer k. Find the smallest integer n divisible by k that consists of only the digit 1 in its decimal representation, like 111, something like 111. Return an integer denoting the number of digits in the decimal representation of n. If no such n exists, return -1. Okay, suppose example 1, the k value is 3. That means we have to find out the length of the number which is consist of only digit 1 and divisible by k. So let's see. So k is 3. So first is smallest number, it is 1. So 1 modulo of 3, it is 0. No. Next smallest number is 11. So 11 modulo of 3, it is 0. No. So next smallest number is 111. 111 modulo of 3, it is 0. Yes. So this is our number. So what is the length for this? Length is 3. Clear? So we have to find brute force approach. What we will check the next number, then next number, then next number in this way. The length is 4. In this actually we can check length is 5 5 1. Okay, now this is the brute force approaches, but what is the number actually it is possible? That actually 10 to the power k value is 10 to the 5 is possible. So this is unlimited number we can check, but there should be some condition, or actually there should be answer will be -1, right? So ultimately when there will be no answer means -1. So suppose, so k value can be uh, 1 2 3 in this 10 to the power 5, right? Value of k 2 to 10 to the power 5. Okay, 2 to 10 to the power 5. So it can start from 2. All right. So if suppose k is equal to 2, is there any possible to have any answer? So what is the condition to be, so any number is divisible by 2, what is the condition for that? That last digit, whatever the number I have, whatever the last digit, that should be even, means 0 2 4 6 8. Then this number only be divisible by 2, right? This is a condition for 2. Now can any number divisible by 3? uh, what is the condition for divisible by 3? That is that the number, the sum of digit d1 digit 1 digit 3 in this way dn, it should be divisible by 3. So this is possible. Something, if it is 111, so sum is 1 plus 1 plus 1, it is 3. 3 modulo of 3, it is 0. So that's why this is possible. Divisible by 3, it is possible. So in this actually, if what is the divisible condition, what is the condition to be divisible by 4? That is that what is the condition for that? Let's Google this. What is the condition to be divisible by 4? We have to check the two-digit number is divisible, is a multiple of 4 or not. The last two digit that should be divisible by 4. That is the condition for 4. So if any number is not divisible by 2, is it possible to divisible by 4? No. Correct? Because what is the condition for this? For the last two digits should be divisible by 4, means something 0 0 0 1 or something like it. Last two digits should be divisible by 4, but last digit are always even odd 1, because here actually the digit actually allowed, that is only 1. So it is to divisible by 4, the last digit should be even, like it is divisible by 4. So something like, if at the last digit we have 3, is it divisible by 4? No, never, it is not possible. So that's why if it is 4, not possible. But if it is divisible by 5, what is the condition for divisible by 5? That is that last digit should be either 0 or 5, the last digit. So, but here actually only digit is allowed, that is only 1. So, do you have any digit whose value is 0 or 5? Not possible. So, if our k is 5, that time also we have to, our answer will be 0. Oh, sorry, -1. There will be no valid answer, right? So, in this we can check. So, basic case is that we have to check that if k value is 0, 2 or 5, then our answer will be -1. Correct? This is the base. But then what will we do? Brute force approach will what? We will start from the smallest number. The number n will start from 1. Okay, and length is also 1. So we'll check that if 1 modulo of k is equal to 0, if it is answer, if it is 0, then we will return our answer length. If it is not 0, then we will generate the next smallest number, that will be 11. We will again check that it is 0. If it is not 0, then actually we will increase the length also. Okay, because we are going to the next number, so next number length will be always increased by 1 because we are actually inserting one digit 1. Got it? So we'll increase the length, and if modulo of k is equal to 0, then actually return the length. What are the length variable actually I have? Now in this we will continue until we found any answer, but it will actually unlimited, like it will actually there is no infinite number actually possible, right? The number range, but there will be some condition. So ultimately what we are trying to do, that we know that there should be some number n, modulo of k should be 0, right? That actually we want to know that what is the n and what is the length for this. Now if we will always start from smallest number, that is 1. 1 modulo of k is equal to 0. Suppose a k value is 3. Okay, so we will start from our smallest number 1. 1 modulo of 3 is equal to 0. No, so our remainder it will be 1. 1 modulo of 3 it will be 1. Okay, and length is 1. Correct. Next, go to the next number. Next number it will be what? Next number n, it will be whatever the remainder actually I have, remainder to 10 plus 1, because we are going to insert a new digit, that value is 1. And now we'll check that modulo of 3 is equal to 0. So what is the remainder value now? 1 into 10 plus 1 modulo of 3, it is 11 modulo of 3. So this is 3, 2, right? This is 2. Now this is the remainder, and what is the length? Length is also 2. For the next number, the n will be, we have to check that 2 into 10 plus 1 modulo of 3. So that is 21 modulo of 3. It is actually 0. Correct? And what is the length for this? 3. So this will be your answer, because the remainder value is now 0 and this is actually 3. Length is 3. So why, you can ask me why actually it will work. So ultimately, if you actually check the remainder only, I know what is the remainder. Remainder means whatever the number n modulo of k. So we'll start from the smallest number 1. Then if I store the k, modulo of k, next whatever the remainder actually 11 modulo of k. In this way I will try to do the 111 modulo of k in this way actually. So if any number has to be divisible by k, that means whatever the number actually it is present, means 11 or 111, that should be also divisible by k, what are the remainder, right? So that's why I can actually use that concept here, that whatever the remainder actually I have, if remainder into 10 plus 1, if it is divisible by k, then this will be our answer. So why actually, how from this point I can easily find out that is there any answer or not. If we found any remainder, we have already visited this, or we have already seen this remainder, that means this is already in loop, because ultimately we are actually inserting only digit 1. That means whatever the actual modulo of k we will do, we will again get the same remainder value, right? Because this remainder we have already seen. Suppose next time, second time we have seen this remainder. So that means again if we add the new digit 1, again we will get the same remainder, means the next same remainder. So there will be no answer. So if any point of time, if we found any remainder is already visited, that time we can stop and our answer will be -1. Clear? Because this will be in loop, because ultimately, suppose let's take another example where actually that our answer will be -1. suppose 7. Okay, for 7, okay, k value is 7. So we'll start from 1. 1 modulo of 7, that is actually 1. Okay, and length is 1. Next is 1 into 10 plus 1, it is 11 modulo of 7, it is 4. Okay, and length is 2. So next is 4 into 10 plus 1, it is 41. 11 modulo of 7, it will be actually 6, and length is 3. Okay, next is 6 into 10 plus 1, it is 61 modulo of 7, it is actually 5. Alright, and length is 4. Next it will be 5 into 10 plus 1, it is 51, and 51 modulo of 7, it will be modulo of 7, it will be 2, and length is 5. Okay, now 2 into 10 plus 1, it is 21 modulo 7, it is 0, and length is 6. So here actually we have found 1 0, modulo remainder is now 0, and this is 6, length is 6. Now you can see that if the length is actually 6, that means 1 1 1 1 1 1 modulo 7, you can check that this number is divisible by 7. Okay, because whatever the remainder actually I have, correct, that number is like if there is suppose 100 plus 10 plus 1, this is the number ultimately. Okay, suppose this is the 111, correct. So if has to divisible by k, that means what, 100 divisible by k plus 10 modulo of k, it should be 0, and 1 modulo of k. If I do the sum of this, suppose k value is 3, to verify this, so 100 modulo of 3, it is actually 1. 10 modulo of 3, it is also 1. 1 modulo of 3, it is 1, correct. Now if I do the sum of this, 1 plus 1 plus 1 modulo of k, 3 modulo of 3, it is 0. Got it? So this logic that if we have any number, if we actually represent in this way, x1 plus x2 plus xn, if all number is divisible by k, right, x1 modulo of k plus x2 modulo of k, in this I will continue xn modulo of k, and if I do the sum of this, it should be divisible by k, it should be 0. Clear? So in this actually, in this approach also we have used the same approach, same logic, that we have actually some number remainder of this, we have already calculated x1 modulo of k. Now actually add this number x2 here actually it is 1, okay, and add the modulo of k. For the next number also, when actually adding the x3, so this is the remainder 1, so remainder 2 will be what? Next remainder 2, it will be remainder 1 into 10 plus 1 modulo of k. Clear the logic? So now go to the code. I hope this is actually easy, just use the concept only. So if our k value is divisible by k 2 or 5, then our answer will be -1, because for 2 or 5 there will be no answer. So it will be 4, it will be 6, it will be 8, for all of this it will be same, because if there is no number possible to divisible by 2, then how it is not possible to divisible by 4, 8, right? So that's why if it is divisible by 2, whatever the k actually I have, if it is divisible by 2 or it is divisible by 5, then return -1 directly. Else I have to check that is it possible or not. So that time what I will do, I need one set to know that this remainder I have already visited or not, means we are on in loop or not. If we are we have already visited this remainder, that means there is no possible answer, so I can actually stop there and return -1 from that point, right? So answer is the current length, and remainder is the current remainder, it is initialized with 0. Okay, and this set is to store which remainder I have seen till now. So while true, this is actually infinite kind of, so I'll stop if I found any possible answer, or if there is no possible answer, that time actually I can break from here. So current remainder will be what? Whatever the remainder actually I have for the previous number. So initially it is 0, it's multiplied with 10 plus 1. Current digit will be added 1, and take the modulo of k, and also increase the answer here is really the length of the number, because I am actually adding one new digit 1, so that's why I actually increase the length of this. So answer plus plus. If our remainder value is 0, return answer whatever the length actually I have. Else this is not 0, then actually I will check that this remainder actually I have currently have I already seen or not. So that's why I will search in this set in this current remainder. If it is not equal to visited.end, that means I have already stored this remainder. So that's why I return -1 from this point. Else store this current remainder into the set and go to the next number, next smallest number. Got it? And ultimately this is the default condition, return -1. Got it? So I have shared this code in the description. This is just use of the number system to the concept of that if any number is divisible by k, then if actually sum of this also divisible by k, sum of this. Alright, here you can see that 111 is divisible by 3. So the condition is that whatever the number actually I have, if I take the modulo of that 3, that sum, the modulo of this number should be also divisible by modulo of that k, or modulo of 3, it will be 0. That is the main concept here actually I have using. Okay. So if you like the explanation, please like the video, and if you not subscribe, please subscribe channel. Thank you. See you in the next video. Bye bye.